Hello everyone, welcome to the Digital Electronics class. In this presentation, we will discuss the T flip-flop, also known as the toggle flip-flop. In the previous presentation, we saw that when we have to only store the data, we use D flip-flop. In JK flip-flop, we overcome the not used state in the SR flip-flop. That is the 1-1 state. That is when the value of the input S is 1 and R is also 1. In that case, we are having the toggling action. Toggling is the control change of output from 0 to 1 and from 1 to 0, which we completed in the last presentation. Now suppose we only want the toggling action. In that case, we will use a flip-flop which we call a T flip-flop. This T here stands for toggle. So for this purpose, we will use a JK flip-flop to obtain the T flip-flop, just like we used SR flip-flop to obtain D flip-flop. But in D flip-flop, we had complemented the input. In this case, we will not complement the input. We will just give the same input so that J and K are same always. And we call this input as T. This is the clock. So we see here that this is a very simple flip-flop which we call a T flip-flop, which has been obtained from a JK flip-flop when we make both the J and K inputs the same. Now let us see the truth table of the T flip-flop. Here we are having clock and T as two inputs to this flip-flop and Qn plus 1 as the output. Now when the clock is low, when the value of clock is low, as we see here, then definitely this flip-flop is not going to operate and the state will be stored. So whatever be the value of this input T, the output Qn plus 1 is going to be Qn. That is our memory. This is a well-known fact to all of us. Now when clock is high and the input T is low, that is when clock is 1 and the value of T is 0, it means again we are having the memory, because in this particular case we are having the value of J is equal to 0 and K is also equal to 0, and whenever such a thing happens, we are having the memory. We have seen this earlier in case of JK flip-flop. It means whatever the previous state is stored and the output Qn plus 1 will be Qn in this case. So again we are having the memory state in this case also. Now what will happen if the clock is high and the value of T is also 1? This is the condition which we were looking for, because when the value of T is 1, then J is 1 and K is also 1, and in this case we find that what we are having? We are having the toggle action in this case. So the output Qn plus 1 will be the complement of Qn, that is Qn bar. This is our toggling. So this is all we have to see in the truth table of T flip-flop. Hope everything is clear to all of you. See you in the next presentation.